Hello all, welcome back to our channel. Here today we are going to see how to construct transition table, state diagram for the more sequential circuit that is given below. Typically it would have a set of flip-flops, one flip-flop or more than one flip-flop, and a little bit of combination circuit associated with it. Now for this we need to derive the transition table, state table. From state table we need to draw the state diagram. Okay, now the first step is to determine the flip-flop equations. Okay, we need to find flip-flop input equations. Now we have two flip-flops, flip-flop A and flip-flop B. So because they are JK flip-flop, the first input would be JA. So JA from the figure we know that is B. Similarly, KA is given by x complement into B. Now for the second flip-flop, that is flip-flop B, input JB is given by x complement and KB is given by x XOR A. Also with this we have one output, that is F. So F is nothing but A XOR B. So these are the three equations that are required. This is the first step. Second step is to derive the characteristic equation or transition equation. Transition equation of JK flip-flop. That is, this equation is going to help us to determine what is the next output. Okay, based on the current input and current output, what is the next output. So the general equation Q plus is given by J Q complement plus K complement Q. Okay, now we are going to substitute this for QA QB. We are going to substitute this for QA QB. So A plus is equal to QA plus, right? So you will have JA into QA complement plus KA complement into QA. So I've just substituted the general equation to flip-flop 1 equation. So again, from the first step we know JA is nothing but B. So I'll write B and I'll retain QA complement as it is plus KA complement okay. So the equation for Ka complement is x complement B the whole complement into QA. Okay. So using De Morgan's theorem, if I simplify this, okay, using De Morgan's theorem, if I simplify this, this is going to be B QA complement plus x double complement plus B complement, right? So this is going to be x double complement, which is going to eventually get cancelled out, plus B complement into QA. Fine. So QA can also be written as A. So my final equation for A plus is equal to B into A complement plus x plus B complement into A. Fine. So this is my transition equation for A. Similarly for B, B plus is equal to, okay, Q QB plus is equal to, you would write the equations in terms of JB and QB. Okay, JB and QB. I am just writing the final equation. This is what we have got: x complement into b complement plus x XOR a complement into b. So this is the final equation for b plus. So these are the two important equations that we need while solving for this. Now, what's the third stage? Third stage is to plot. Third stage is to plot the transition table. Okay, third stage I'll write here. Third stage, transition table. Now, how do we write the transition table? So, what are the contents? Transition table will contain present state, next state, and your output. Now, next state will depend on two things. Okay, my present state will have AB, okay, and x is equal to 0, x equal to 1. Similarly, here this will be f is equal to a XOR b, because this is a Moore model. Right? We need to determine two things. That is, when I have a, b, I have to determine a plus b plus when x is equal to 0, a plus b plus when x is equal to 1. Right? So, combinations 0 0, 0 1, 1 0, 1 1. Now, what do we do? Take this equation 1 and equation 2. Substitute the values of a is equal to 0, b is equal to 0, x is equal to 0 and solve for equation 1. Okay, b is equal to 0. So, this term b into a complement in equation 1 will be 0, x plus b complement will be 1, into a is 0. So, the entire solution should lead as a plus as 0. Similarly, b plus will be derived as 1. Similarly, when it is 0 1, it is 1 1. Again 1 0 is 1 1. 1 1 will lead to 0 0. Okay. Similarly, when x is equal to 1, solve it, you will get 0 0, 1 0, 1 0, 1 1. These values I am getting from equation 1 and 2. Okay, you need to substitute values for a, b and x. Similarly, for output it is direct equation a XOR b. So, this is going to be 0 1 1 0. Fine. Now, here this is the most important step, to draw the state table. Okay. Fourth step is to draw state table. Typically what we do is, if we have one flip flop, we have two output possibilities, that is 0 or 1. Now we have two flip flops, so we have 4 combinations. Okay, 0 0, 0 1, 1 0, 1 1. So each state or each combination will assign a state. Say assume A is assumed as, or A is assigned 0 0, B is assigned 0 1, C is assigned 1 0, D is assigned 1 1. Right. So whatever we have here, we shall be writing it in terms of states. Right. So let me continue. Present state, next state, output. Present state, next state, output. Similarly, for x equal to 0, for x equal to 1, right? Similarly, I will have my a plus b plus a plus b plus and my output f equal to a XOR b. This will remain more or less the same thing from the previous one. So, now I have 0 0. So, 0 0 I have associated with state A, okay. 0 0 I have associated with state A. So, I will write here state, present state, okay. Let me also write this as AB. So, present state is A, next state is 0 1 meaning B if x is equal to 0. If x is equal to 1, stay in the same state A and the output is 0. Similarly, for B, if x is equal to 0, go to state D. If x is equal to 1, go to state C. Output is 1. Similarly, when it is in state C, D, C. State D, when it is in state D, when input x is equal to 0, go to state A. When input x is equal to 1, go to state D and the final output would be 0. Understood? So, this is how we get the state table. Now, how do we draw the state diagram? That is the final part of it. The state diagram is the final part of it. So, let me just quickly sneak in here. Okay. So, fifth step, I am writing it here because of the space constraint, is to draw the state diagram. So, how many states do we have? We have 4 states, and you can observe whenever we were in state A, output is 0. Whenever we were in state B and C, output is 1, right? And whenever we are in state D, output is 0, because this is a Moore circuit. So, while writing, you can write A slash 0 B slash 1 C slash 1 D slash 0. Okay. Initially, when we were in state A, okay, when we are in state A and if the input is 0, we go to state B. So, we will write arrow mark in this direction, input is 0. If input is 1, stay in the same state, right. If input is 1, stay in the same state. Similarly, when you are in state B and your input is 0, you go to state D. When you are in state B and your input is 1, go to state C. Similarly, when you are in state C and your input is 0, you go to state D. You are in state C and your input is 1, you stay back here. Similarly, state D, you go to state A if your input is 0 and state 1 if your state D if your input is 1. Fine. So, this is how we do the state diagram for the given equation. Thank you.